This is section 12.4, the normal distribution. Normal distribution is also called a bell curve or a Gaussian distribution. It is bell-shaped and symmetric. The mean, the median, and the mode are all equal and located in the center of the distribution. So these are all examples of normal distributions. Notice how the left side looks like the right side, and it's highest in the middle. And this middle would be the mean, it would also be the median, and the mode. The shape depends on the mean and the standard deviation. So each of these three graphs have the same mean. So let's say the mean is 10. So this would have a mean of 10, 10, 10. But notice one is skinnier, one is fatter. That has to do with the standard deviation. So the larger the standard deviation, the more spread out the bell curve is. So this would have, this graph right here would have a larger standard deviation than this one. This is called the 68, 95, 99.7 rule. What this says is approximately 68% of all data items when we have a normal distribution fall within one standard deviation of the mean in both directions. So if this is the mean right here, then you're going to have data items below the mean. You're going to have data items above the mean. And if we just look at one standard deviation below and one standard deviation above, then this portion right here, one standard deviation below and one standard deviation above, will account for 68% of all the numbers in this data set. "95% of the data items fall within two standard deviations. So if you go two standard deviations above, two standard deviations below, which is this portion of the graph, 95% of all data items, 95%, are going to be in this area right here, which is two standard deviations below, two standard deviations above. And finally, 99.7, all data items in a normal distribution are within three standard deviations. What this says basically is there's hardly anybody that's going to be more than three standard deviations away from the middle or the mean. Male adult heights are approximately normally distributed with a mean of 70, standard deviation of 4 inches. Find the height that is two standard deviations above the mean. So standard deviation is 4. We want two standard deviations above the mean. All right, so if 70 is the mean, and I do one standard deviation above, that means add one standard deviation, which means add 4. Okay? If I want to do a second standard deviation above, I would add another standard deviation, and again, the standard deviation is 4. So the height that is two standard deviations above the mean is 78 inches. Use a distribution to find the percentage of men with heights between 66 and 74 inches. So to figure this one out, you have to figure out how many standard deviations away from the mean you are, which will tell you the percent. So first figure out how many standard deviations, and then that will tell you the percent. So remember the mean is 70 and the standard deviation was 4. Standard deviation was equal to 4. If I add 4, that will give me 74 inches, which will mean 1 standard deviation above. And if I subtract 4, that will give me 66, which is 1 standard deviation below the mean. So I went 1 standard deviation above, and I went 1 standard deviation below. So 1 standard deviation, that's 68%. A z-score. It describes how many standard deviations a data item lies above or below the mean. This is the formula. You will need this formula. Make sure you write it down. If we have a data item above the mean, that's going to have a positive z-score, and a data item below the mean is going to have a negative z-score. If we have a data item that is exactly the same thing as the mean, it's going to have a z-score of 0. The mean weight is 7. Standard deviation is 8/10. We want to find the z-score for a weight of 9. When I say the weight is 9, that's the data item. Okay, so when you substitute into the formula, I say the weight is 9, so that's the data item that we're trying to figure out the z-score for. Subtract the mean. Well, they told us the mean was 7. Divided by the standard deviation of 8/10. Z-score is going to be a decimal. 9 subtract 7 is 2, divided by 8/10, and you get 2.5. Notice 9 pounds is above 7 pounds, which would indicate that we have a positive z-score, and indeed we do have a positive z-score. IQs are normally distributed with a mean of 100, standard deviation of 16. What is the z-score corresponding, or what is the IQ corresponding to a z-score? So we're trying to find the data item this time. I'm giving you the z-score, and we need to find the data item. So remember the formula. We take the data item, subtract the mean, divided by the standard deviation. Okay? I know the z-score is negative 1.5. I don't know the data item. Subtract the mean. The mean is 100. And the standard deviation on the bottom is 16. Now you want to solve for D, okay? Before you can solve for D, you have to get rid of this 16 in the denominator. What this says is divide by 16. So I have D minus 10 divided by 16. The opposite of divide is multiply. To get rid of the 16 in the denominator, you're going to want to multiply both sides by 16. And notice on the right-hand side, this 16, when we multiply, we don't actually multiply through because the 16s are going to cancel. So I'm going to erase this and write a little bit smaller. We have 16 times negative 1.5 is equal to the data item minus 100. Remember, we're trying to get the D by itself, and yes, you guys would multiply that. Offhand, I don't know what that is. So, hold on a second. 16 times, so we got negative 24 is equal to the data item minus 100. We're trying to get the D by itself, so we have to get rid of the minus 100. So add 100 to both sides. And negative 24 plus 100 will give us 76. Notice 76 is lower than the mean of 100, which should make sense because we have a negative z-score. This is a long section, so I'm going to stop the video here, and this will be the end of part 1. I do have a part 2.